All right, let's continue this part A. Here we go with number 21. All right, we're identifying any excluded values here. That's important. And then simplify the expression. So real quickly, like factoring things is good. Excluded values involves setting the denominator equal to 0. So if there's any single factor after you factor it all out, if there's any single factor that could be a 0, just set it equal to 0. So b minus 2 equals 0, and add 2, and so b equals 2. This is the only 0. You should only have one excluded value, and you just say b can't equal 2. So b cannot equal 2. All right, now let's just factor this bad boy and see what happens. So I'm going to take things out of here. First things is GCF, GCF, GCF. So always get your GCF out of there. So this is 7 times b squared minus 4 all over b minus 2. Now when you see something like this, difference in perfect squares, you know you can rewrite that as 7 parentheses, and b squared minus 4 is b plus 2, b minus 2. And usually in a problem like this, they're going to kind of, I would always notice that, hey, they're probably going to give me something to cancel out here. So there's a good chance that b minus 2 is a factor in there. So if you do it right, there should be some cancelage going on. So that's just a little pro tip there. But when you do that, you can now cancel these two, and don't forget your excluded value. So my final answer is 7b plus 2. Or if you distribute it through, that's okay as well. But generally, you can just leave it factored there. 7 times b plus 2 with b not equal to 2. Good stuff. Let's go to this one. It says solve the system. Now, we did this kind of stuff, and it was tough to do it by hand, right? Because it involved so if you're going to do this by hand, let me cover this up here. If you're going to try this one by hand, what it involves is, I'm not going to do it, but I'm just going to show you if you feel like you want to do it. You pick two equations. So let's say I pick these two, and you use elimination to get rid of one of the letters. Once you get rid of one of the letters, you're going to have a single equation with just two letters. So let's say I decided to eliminate my x. So I multiply this entire first row by 7. Now they're opposites. I add them together. I get a new equation with no x's. I just have y and z. Then, this is for those who are going this direction, then you would have to go into pick another pair. So let's say you want to pick, I should have done z's, but that's all right. Then you pick two more equations. Let's just say these two. You use these and elimination again and try to eliminate the x's again. So you'd multiply this row by 2, this row by -7, and then they would be opposites. One's 14 and one's -14. And then you'd cancel those out, and then you'd have another set of equations with just two letters. Once you have equations with two letters, you know how to solve those, so you're good. Now, all that to say, this is not what I'm going to do, okay? What I prefer to do is go with matrices here. So especially a 3x3, why not, right? So a 3x3, let's just write your coefficients. So 1, 3, 3. This is -7, 5, and 1, -2, -11, and 1, times your variable matrix, which is x, y, z, equals your constant matrix, okay, which is -3, -17, and -99. Now you say to yourself, how do I put this in the calculator? Well, put this one as a times x equals b, okay? And the shortcut method is ultimately you're trying to get to x, just like before in that other one we did, is equal to a inverse times b. And as long as you plug it in right, this will work every time. All right, so let's plug that in, and for a and b, and we'll be good. So I need to change this one. Oops. I always do this. Go to matrix edit, not pick the matrix. And I'll pick a. Cool. So I'm going to pick A, and I'm going to go change my dimensions from 2 by 2 now to 3 by 3. And your interface might look a little different, but it's the same, really it's the same function. So you should be good here. So I'm just going to put those in, 1, 3, 3. Where was I? Oh yeah, -7. Oops, not 0.7. -7, 5, 1, -2, -11, and last is 1. Okay, so these are all my equations. These are our coefficients. All right, coefficient matrix, done. Now go back to matrix edit, and let's edit B. This is now 1 by 3. And I'll just put those, this time I'm putting the answer matrix in, so this one here. So let's throw that in there, the constants matrix. So this is -3, enter, -17, enter, and -99. Okay, there are potential for mistakes just by carelessly putting numbers in, so just double check, make sure everything's looking good. Okay, so I'll go to second quit, and then again, just go to matrix. We'll do A, go to names first, hit A, inverse, and then matrix again, names B. A inverse B is always the answer, always the technique here. So when you do A inverse B, you should get 6, 7, and 10. You can write it as an ordered triple if you want, just like an ordered pair, but 3 of them. So this is going to be 6, 7, and -10, just like that. You could just write that, or you could write x equals, y equals, z equals. And there are my solutions. Sweet. That's amazing. All right. This is just as easy with a 4 by 4 or a 5 by 5, and that would take hours to do by hand. So good job. All right. It says find the equation of the parabola. All right. Parabola here. How do you find it? This is just like y equals mx plus b. Okay, just like a straight line, except the formula is different. So you have to know, this is one you want to jot down here, y equals a parentheses x minus h squared plus k, where hk is your vertex. So your vertex is always, oops, let me put h first, hk. In other words, whatever the x value is your h, your k is your y value of your vertex. So memorize this formula. We're going to be seeing it over and over and over and over and over and over again. Okay, now let's plug in all the letters we have. So my h and k are here. This is just a rando x and y that go together. So just put, this is x, this is y. And what I want to do is here, I'm going to put 1 in for y. And the only letter I don't have is a. Once I find a, I am done. I am a-okay. So just leave a there. And now do x minus h. So the x is 4 here. So 4 minus, my h is 2 squared, plus my k value, which is -6. All right, now you go through this whole process here. Simplify. 4 minus 2 is 2. 2 squared is 4. So this would be 4a minus 6 equals 1. Add 6 to both sides, and this would be 7 equals 4a. Divide both sides by 4, so a equals 7 over 4. So the moral of the story, keep everything except the y and the x. So just write it as an equation here. So I've got, look, I've got this, that's good, okay? I've got my h and my k from here. So just leave all those things in there and just write the equation as it would be. So y equals 7/4 times x minus h. So just leave x in there just like you would do y equals mx plus b. So x minus, now h is a steady number here, it's always the same vertex, and that's going to be 2 here. X minus h, and then put the square in there because that's where we get this from, and then plus k, which is a -6. You could do -6 as well there, and that's right. Okay, so take a second, think about this, and make sure you lock in this formulae right here. Okay, good stuff. Let's keep it rolling. Simplify. 5 to the -6 power is the same as 1 over 5 to the +6 power. And something like that, it's pretty simple. 5 to the 6th power is 15,625. So it's 1 over 15,625. Done. Now that was fun. All right, let's find A times B. So first thing to do when you're multiplying an A and a B is really to check your dimensions. So this is 3 rows, 2 columns. This is 2 rows, 2 columns. So the question is, can you multiply these two? The answer is yes. Just check your middle numbers, and you're good to go. All right. Now, yes, you could put this in the calculator. I'm going to do this one by hand. These are really easy to do by hand. So I would probably do both. If it were me and I had infinite time, I'd go for that. All right. So I'm going to take this row. I'm going to stand it up. Let's take this row and stand it up next to this column. What does that mean? That means this first element, 8, negative 8, is going to be multiplied by negative 2. Oh, what's my answer going to be look like? The answer is going to be a 3 by 2. That's the outside numbers here. So that's good to know as well. So my answer's nice 3 by 2 when we're done. All right, so negative 8 times negative 2 is 16. So it's going to be 16. Just write that down. And then negative 7 times negative 10 is positive 70. So plus 70, just like that. Okay. Now take that same row and now multiply it by this. Stand it up next to this one. So negative 8 times negative 8 is 64. And negative 7 times negative 10 is 70. So do 70 like that. Okay. Next up is the next row. So take this row, stand it up next to this one. So 8 goes with the 2, 5 goes with the 10. Let's make it happen here. So 8 times 2 is negative 16, 5 and 10, and so that's going to be plus a negative 50. Okay, and the next column, so 8 times negative 8 is negative 64, and 5 times negative 10 is negative 50 again, so plus negative 50. All right, this is fun. Okay. And we'll go to the final one here. 1 times negative 2 is negative 2, and 3 times negative 10 is negative 30. Okay, and now the last column is going to be 1 times negative 8 is negative 8. 3 times negative 10 is negative 30. Okay. All right, so we're just going to simplify each of these and we'll be good. So you should get 86, 134, negative 66, negative 114, negative 32, and last to be negative 38. Okay, so a little bit of work, but hey, doesn't hurt you, right? All right, not too bad, not too bad. All right, next one, subtract. Subtract. We're going to first, when you see subtract, I want you to freak out and turn this into, like, Smotto the mess out of this. So here we go. Watch how I Smotto. Ready? Subtracting in front of something else. Just change this to a plus. Now change all the signs. Ready? Here we go. Boom, boom, boom. Smotto that whole thing. It only applies to the ones after because that's what was being subtracted. Now I'm an adding problem, and an adding problem doesn't need these parentheses, so I can just focus on what's the same. So this term is the same as this term. This term, which the negative's included, is the same as this term, and then the other one's just a loser, kind of hanging out for the ride. So negative 13 x to the 4th minus 7x to the 3rd, and last one is we still need the negative 21 there. So there you go, simplified just like that. Solve the system by graphing. Well, great way to graph is to solve for y in this one, so let's do that. And other ways are like the cover-up method, like I talked about. What's the cover-up method real quick? Actually, that wouldn't be too bad here. Cover-up method looks like this. So I take my, I cover up this one, and I get negative 2y equals 4. Well, how do I solve that for y? This would be what happened if x was 0, by the way. So how do I solve this? Divide both sides by -2. So divide both sides by -2, I get -2. So what does that mean? Y is -2, so put a dot where y is -2. Okay. Now let's undo that cover up. I'm gonna move it over and I'm gonna cover this up now. This is the cover up method. Okay. I don't know if it's gonna cover up very well, but we'll see. Being stubborn. Whatever. All right, so this time -x equals 4. Solve for x, divide both sides by -1, and I get -4. And so -4 is my x value. So put a dot at -4 on the x-axis. Okay. Now, you might say to yourself, this is too complicated. I would just put this on a just graph it. I would graph it differently or whatever. I get that. That's cool. That's cool. I would just do y equals mx plus b. Totally fine. Do y equals mx plus b. It's totally good. Get out of here. All right. Now, this is what I'm going to do. I'm going to use the cover up method here. And so what I do is just draw a line through those there and then extend them and make sure everything's lined up correctly. It's looking pretty good. Okay. Now, second one, I'm going to do cover up again. Again, it only works if the things are kind of far apart and all that stuff, so we'll just kind of see what happens here. As I cover up this one, I divide both sides by -4, and I get 3. So my y value is 3. So put a little dot at +3. Okay. The second one, I'm going to, let's move that rascal. Okay, kind of works. This time we'll divide by -12, and that would be 1. So this other point is +1. So this can be a dot right here. And this is kind of what I'm talking about. You can see where you can kind of pick out the slope here and stuff like that. But essentially that's all you need. And I'll just draw my other line here. And let's use the color pink. Let's see. And it looks like they're going to cross right about there. And they cross nicely at that single point there, and all you do is find this point right here and talk about it. So this is going to be +2, -3 should be your solution. So 2, -3. So you guys kind of know how to solve for y if you chose to do that, but the cover up method is pretty quick too if you understand it. So whatever floats your boat, there it is. You can also use your calculator on this one unless you are asked to draw it. So but there we go. Let's use Kramer's rule. Who saw this one coming? Okay. Kramer's rule is using some determinantes. So remember, Kramer's rule is you start out by setting, okay, and set it equal to this one. Not equal to, wow, it's been too long. But this is your x and this is your y. They're just the determinants of these things. So well, here's what I do. Put all your things in there. So this is -7, -10, 6, -4. Do it for all of them. Okay. -7, 6, -10. All I'm doing is putting is the coefficients in here. And -4, and -7, -10, 6, -4. All right, so all I did is just wrote this out, and this is potentially my solution. So how do you do this here? So now what we need to do is fix the tops, okay? Because all I did was kind of set it up. All right, now what I do to fix the tops, if I want to find the x's for the first one, what I do is I erase these two where the x's would be, and instead I put the answers 32 and 8. Okay, now on the other ones I'm going to erase the y's. So let's erase the y's, and I'll use 32 and 8. Okay, do you get that? So it's really simple. So just make sure you set it up the right way. Now it's just a matter of finding some determinants. So you remember your determinant tricks. Go down and back. Okay, so it's the down and then minus the backs. So as I do this one here, this is going to be negative 7 times negative 4. That's positive 28. So this is 28 minus the backs. All right, so this is 6 times negative 10. That's negative 60. So that's going to be a minus a negative, so it's plus 60. Okay, now that's identical to this one here, so there's no point in doing that twice. So my denominator each time is going to be 28 and 60, so that's 88 is my denominator. Oops. Okay, good stuff. All right, this is fun. All right, let's do this. And so this one we're gonna do the same thing. We're gonna use the Cramer's rule, down and back. So here we go. 32 times negative 4. Let's see, 32. Let's do this all in the calculator here. 32 times negative 4, and it's 128. And then we're gonna subtract the other product, 6 times 8. So 128 minus 6 times 8 is 48. So minus 48, and I get negative, yeah, that would be right, negative this is what was it, 176. Okay, so right up here, negative 76. Okay, so that one's done. Let's do this one over here and see what we come up with. So this is going to be same deal. Negative 7 times 8, negative 56 minus, and then go back the other way, 32 times 10, so minus a negative, so that's positive 320. Cool. And negative 56 plus 320 gives us 264, so this is all 264 on this top. And then, of course, the simplest thing would just be to divide those. So 264 divided by 88 is 3. So this all just turns into a big fat 3. And my x value is 176 divided by 88. And that's 2, so it's been negative 2. Okay. So there we go, negative 2, 3. So kind of a long way to go, but if you're good at determinants, this is actually really quick. Okay, so just make sure you can set it up right, and you're good. All right, change 924 inches to feet. So 924 inches needs to be changed to feet. That's really easy. All we need is conversion factor. So put inches on the bottom, and then feet on top. Okay, we want our inches to cancel, so bam, bam. And all we're going to do is put 12 inches here is 1 foot, because that's equal to 1. And then just let the things, the units will tell you what you need to do. So this will just be dividing. 924 divided by 12, done. 77. Okay, so 77 feet. Okay. Very handy. All right, let's go to number 30. Solve the systems by substitution. Substitution, this is kind of easy enough. But the key on substitution is to solve for one letter. So I just pick your favorite letter that is the easiest to isolate. So in this case, maybe this y right here is the easiest one, because it's got just a 2 there. So what does that involve? That just means solve for this first. So I'm going to add 7x. And I get negative 2y equals 7x plus 32. Okay, divide everything by negative 2. And I get y equals a negative, I'm going to change it to a decimal just for fun here, because I'm not really graphing it anyway. And then this is going to be minus 16. Okay, now here's the cool part. If y is equal to this thing right here, that means everywhere you see a y in the other one, you can plug it in. So that's what we're going to do now. So we're going to do 7 parentheses. Instead of y, I'm going to write negative 3.5 x minus 16, like that. And we'll do plus 3x equals 17. All right, now let's work it out. This is going to be 7 times negative 3.5 gives me negative 24.5, and x minus 7 times 16 is 112. Okay, now it's just a little bit of algebra here, nothing major. Negative and positive signs are different, find the difference. So this is negative 21.5x, and I'll add 112 to both sides, so that equals 17 plus 112 is 129, and we'll just divide both sides by negative 21.5, and I get negative 6. Okay, so all that to get negative 6. Now what do I do once I have negative 6? Best place to plug it in is, you guessed it, plug it into the box. It'll give you y the fastest way possible. So this is negative 3.5 times x, which we know is negative 6 now, minus 16, and let the calculator handle that. Negative 3.5 times negative 6, use parentheses in your calculator too, it's always helpful, minus 16, and I get 5. Y equals 5. Okay, so I got my two solutions. Things are looking good here. And so I got x and a y, and that's all they needed. You can write it as an ordered pair at that point. Good stuff. Let's see what's up next. Graph and state the domain and range of the discrete function. Yeah. I'm not going to say anything. All right, that was insulting. All right, let's move on. All right, it says a line with a slope of 7 crosses the y-axis at the point. Oh my gosh. All right, so this right here, guys, crosses the y-axis at this point. This is the definition of y-intercept, also known as b. The slope is 7, that's m. So just literally write y equals 7x plus 11. That one was too easy. But we need some easy ones in there too, right guys? Right. Okay, here we go, number 33. Write this equation in standard form. Standard form is just to get y by itself, guys. So let's, what's gonna be the easiest way here? I could save a step if I moved y to the left and moved x's and everything else to the right. So let's do plus y, and I'll subtract, and minus 15, minus 4x, and minus 15. Okay, and so now on this side, I'll just think these will all cancel out, which is fine, and I'm just left with y equals negative 4x squared minus 4x minus 15, because these will be going on this side. And I think that's all we have to do. It looks good to me. All right, good stuff. All right, identify excluded values and simplify the expression. Okay, well, let's move through this. This is a good one. I think a lot of you should watch this one because this is a good one that you're going to see again. All right, key, factor. Did I say factor? Yes, factor. All right, so factor as much as you can. It'll simplify things, it'll make it much easier to see and save you steps later. So first thing I'm going to do, bust this thing up with GCFs. Okay, so GCF, the top. Sounds like a 4 could come out of that mess. All right, so 4 goes into, so this is going to be x squared minus 5x, right? Not 5x, this is 10, goofball. Or no, yeah, no, this is minus 5. Minus 5x, forgot what I was doing. And then 144 is 36. Okay, minus 36 all over, and then we'll take a 3 out, and we got x squared plus 6x, and then plus 8. All right, so that's fun, right? But now we got to get to the fun part of factoring, where we take the different pieces apart. So let's do that. Let's see, we got 4 still carried along for the ride, and we're just going to break this up. X and x. And 3 goes out here, and again, x and x. All right, now how does this factor? All right, there's a lot of great ways to do this, but just a simple way on this one is just to say, what makes 36 that would have a difference of 5? So what are the factors of 36? Think through them. 9 and 4. So 9 and 4. So do 9 and 4, because when I subtract those, I get a 5. The 9 must be negative. The 4 is positive. Okay? Now, second step, we'll go to the next thing. Chances are they're going to want us to cancel this out. So this is a little cheat for you. Put plus 4 on one of those. Doesn't matter which one, because there's a good chance that's what you're going to use. So 4 times 2 would add to 6. 4 and 2 is add to 6, and then 4 times 2 is 8. So good to go there. All right. So before we get too far, let's not forget our excluded values. So excluded values are anything on the bottom that would be a 0. So just pretend they are 0. What if x plus 4 equaled 0? Well, that means if I subtract 4, x is negative 4, which means x cannot be negative 4. The other one, x plus 2 equals 0. Subtract 2, x equals negative 2. Uh-oh, that can't be 0 either. So you got 2 excluded values. You got to make sure you state those, okay? All right, next thing, cancel. Let's cancel some things out. Bam, bam. Those guys are gonzo. We already identified the excluded value, so we're good. Let's just write our solution now. This is going to be 4 times x minus 9er and 3 times x plus 2. Now you might say to yourself, can't I factor that x minus 9 to something? No, it's not 2 squares. The 9 is square, the x is not squared. So these are actually as simple as can be. You do not need to multiply those through. Leave it like that. This is a good answer right here. Okay? Okay, solve the system, decide whether it is consistent or inconsistent. So this is one of those things, guys, where I'm going to do the matrix again, but if we have a problem, we got to figure out how to identify which problem it is. So let's look at the matrix and see what happens on this one. Now, another good hot tip you can look for is, like, is there a number? Does one look like a multiple or duplicate of another one? And as I'm looking through, it's possible that this one and this one are going to be problematic. Maybe you can identify it here. Notice how 7, if I multiply this top row by 3, all my letters and stuff would cancel out, right? Because this is just a multiple of 3 from the other one. And that's the hint I'll give you guys, is that if they're asking, determine whether the system is consistent or inconsistent and stuff like that. That's what they're looking for here. So you know what, I'm going to hold off on the matrix here because I can just spot it right now. So here's how you know. When I multiply, multiply this row. Let's say I multiply this row. Let me get this silly thing out of here. Let's say I multiply the first row by 3. Okay, remember you can always multiply a whole row by something and it's fine. Let's rewrite it down here. This is 21x minus 12y minus 30z equals, and then this would be like negative 33. Okay, now if I made a negative version of this one, if I multiply by negative 3, this would just be all the opposite signs. And when I add those up, what would happen? Watch what happens here. Bam, 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 bam. Or you could just subtract them in your head. Bam, bam. And then negative 77 and positive 33, that's negative 44, equals, what's left on the left side? 0. So, is it 0 equals 0? No. It is 0 equals negative 4. Is that true? No. So what kind of system do we have? That is an inconsistent system. We just say no solution. Okay? If you can manipulate your equations to where they look identical and you subtract them, you get 0 equals 0, that's when you have infinite solutions, and that's a consistent but infinite solutions. You're good there. Okay? So hopefully that made sense for you. All right, let's graph this bad Larry here. Remember the parent function x squared, y equals x squared. That's really easy to do. This one's just shifted over. So my parent function is like this. So like 1 squared is 1, 2 squared is 4, so it jumps up there, and negative 2 squared is also 4. And so then you get this nice parabola. There's parent function. Now, let's go to this guy. How did he shift? Remember, x is opposite, so it's going to be, instead of to the right 4, it was actually left 4, so left 4 units, and also down 2 units. So take your vertex, move it left 4, so and down 2. Okay, so there is my vertex. Now, you follow the same pattern. Go right there, right there. Follow the same pattern. Okay, go up to where 4 would be, or go up 4 from your vertex, and on the other side too. Follow the same pattern you were doing on the other one. And if you know the next one, it would have been 9, so it's 9 above here, that is. And so you have a nice parabolic shape. And happy birthday, we got a winner. Okay, hopefully that made sense for you all. Okay, good stuff. So draw your parent function, and then draw whatever changes happened on that one, and you're good. Multiply and evaluate for negative 5. So let's multiply first, and evaluate for negative 5. We're on 37. We're almost done, guys. We got this. Starting to get tired. We can do it. All right, you got perfect squares up here, guys, and that indication, that should indicate to you this is going to be 5x plus 6 and 5x minus 6. Because it's up here, there's a good chance one of those factors is going to be in here, probably the 5x plus 6. So that's a good hint for later when we're trying to figure out what this is going to be. All right, this is still x plus 2. Just connect your, when you multiply, you just connect them like this and make it one big one. So this is going to be x factored out of here. This is x plus 2 here. And then down here, this little mess here is going to be, let's see, 5x. I'm going to guess that it's plus 6 for one side. And then this is going to be x plus 1 maybe. Let's see. Outer would be 5. Inner would be 6. That's good. And then outer, let's see, this would be 6. And 5 times, yeah, this is looking right. All right, so I just had to double check that in my head, sort of. All right, so now, before you get too wild here, let's check for excluded values. They didn't ask for it, but let's do it anyway. Over here on the side, x not equal to, so x plus 2 equals 0. So x cannot equal negative 2, or that's a problem. So there's 1. 5x plus 6 equals 0. Subtract 6, divide by 5, and x cannot equal negative 6/5. And the last one, x plus 1 equals 0, so x cannot equal negative 1. So there's 1, there's 2, and there's 3 excluded values. Now let's get to canceling. Okay, this is fun when it all cancels out. So bam, bam, that was fun. Bam, bam, that was also fun. And now we're down to 5x minus 6 times x. I'll put the x out here in front. And all over x plus 1. Okay. Now it tells us to evaluate for 5. So don't get all excited that you're done. You still got to plug in that negative 5. So let's do negative 5, parentheses, 5 times negative 5 minus 6 all over negative 5 plus 1. Okay, use parentheses when you're subbing in for an x. So let me do that and make sure. It's also easy to see where you put them in as well. So, all right. So let's solve this thing here. This is 25, negative 25 minus 6. Let's do it in the calculator. So I'll do negative 25, negative 25 minus 6 times negative 5 divided by negative 5 plus 1 is negative 4 divided by negative 4. So this is negative 38.75 is what I got. If you left it as a fraction, it would just be negative 155 over 4. That's probably as simple. I think that's as simple as it gets right there. So either of those should be good answers. Good answer. All right. Okay, let's find the inverse of this. Okay, remember the formula for the inverse. We need to find the determinant first. And so the inverse formula is 1 over your determinant, so like this, times, and then you switch the a and b and negate the other two. So this would be negative 3, negative 1, and then this would be negative 2, and this would be positive 1. So switch and negate them, and then we'll put the determinant of this thing in that little fraction, then we'll multiply it through. It'll be good. All right, so let's do determinant real quick. Down first, and then minus the back. Okay, so down first, then minus back. So this is going to be negative 1 times negative 3 is positive 3 minus negative 2. So that's this is 5. Okay, so this is going to be this whole thing down here in the denominator is just a big fat 5. Okay, so it's 1/5 of all those things. So if you work that out, 1/5 of those would be, should have had, let's see, 0.6, negative 0.4, and 0.2, and negative 0.2. Okay, so I think that's all good. All right, 2 more. We're almost there, guys. We got this. We got this. Here we go. Graph by solving for y to attain slope. All right, so this is just an easy one here. Subtract 10 from both sides for 4y equals negative 10x. Negative 10x plus 40. And we'll divide everybody by 4. So this is y equals negative 10 fourths. Well, let me reduce that to 5 halves. So 5 halves x and plus 10. That was easy. All right, 5 halves, okay. Now we'll just plot the points. So we'll start at the intercept, which is way up here at 10, and then my slope is negative 5, 2, which means drop 5 and run 2. Drop 5 and run 2. Drop 5, run 2. All right, that's enough of that mess. Let's make a nice line out of it. And sorry, too precise. All right, so this is a pretty good line here. And it says something for what it is. Okay, there's slope intercept form, and I graphed it. We're good. Last one, here we go. Find the zeros of the quadratic function. Conjunction, junction. So what does it mean to find the zeros? That means when does this whole thing equal 0? 1, 4, 4. Now, 2 options here. You can obviously divide this thing by 4 and simplify it a little bit, or you might even just jump here and say, hey, these are both perfect squares. It's actually another way to do it is to add 144 to both sides, and then take the square root divide by 100, take square root, and you'll get the little fraction answers there. So there's a lot of ways to do this one. I think you'll probably do that. You'll probably want to do this. You'll recognize that these are perfect squares. So this would be 10x plus 12 and 10x minus 12. Now, if you decided to divide by 4 first, you would have 25x squared minus 36, and that would factor out nicely as well. So if you decide to divide up both sides by 4, that's a fine way to do it. It'll just sort of save a little bit of work later. All right, so now we've got two things multiplying to make 0. Use my magic trick to say 10x plus 12 equals 0, or 10x minus 12 equals 0. And we'll subtract 12, add 12. Anyway, 10x equals negative 12. 10x equals positive 12. Divide both sides by 10. You reduce it, and x equals negative 6/5 is a fine answer. Or x equals positive 6/5. Okay, so 2 solutions, all good there. And I think we are, wow, we're done. Cool. All right. It is almost my bedtime, and I turn into a pumpkin any minute now. So anyway, keep working hard, guys. I appreciate you. If you got other questions, make sure you send me an email and stay after or whatever you got to do. Good luck on the test.